Hey, Joy. Good afternoon.
Good afternoon, Frank. Hi, everyone.
Oh,
Let's wait a little bit for others to join, and then we can start.
just we are two, three. How are
Hey,
you?
I'm
How are
pretty good.
you? Come on, Joy. How are you?
I'm good. I'm
Good,
good.
good.
Thank you. Thanks for joining.
What we will do today?
So today's
Great.
will be a technical session from Chainlink. So if you are looking to integrate Chainlink in your project for the hackathon, definitely this is the place for you. Now we are waiting a little bit for other people to come in, and then we will start soon.
You are from Hong Kong at this moment, I think.
I'm not. You mean me?
Yeah.
No, I'm not from Hong Kong. I'm now in Berlin.
Okay. Just so it's just background. It may be useful for my projects to use the Chainlink. I will integrate Chainlink to other cryptocurrencies for my projects. So I will do this maybe this week, or because I'm running on side developments. So anyway, I should be able to add Chainlink to other cryptocurrencies. What's up, Frank?
Hey, what's up? How
How are
how
you?
how how to pronounce your name? Benrona?
Bin Rawan Sufyan. Okay.
Yeah, welcome to this workshop. Actually, we have an ongoing online hackathon globally from Chainlink Labs. If you are interested in that, or if you have some project integrated with any Chainlink services, you may just submit your project to Chainlink Hackathon. I will introduce in the workshop too.
Thank you. Thank you, Mr. Frank.
Are you Germany?
Me?
Yeah.
Algeria.
Yes.
Algeria. Algeria. No,
Frank, I think we can start already because the video is being recorded. So if other people join in later, so they are able to watch the video. Anyway, I think if you have any questions, please take a note, and after Frank finish the session, so we can discuss about your question later. So Frank can run the technical session smoothly.
Okay. Yeah, let me just share my screen. Oh, I do not have a permission. Can you grant me the permission to share my screen?
Please try again.
Yeah.
Okay.
Good. 1 second. Okay, cool. Let's start. Okay, so first, I just want to say thank you for everyone to come to this workshop. This is a workshop from Chainlink Labs, and in this workshop, we were going to introduce some services from Chainlink Labs, including some data service and computing service, but we will focus on the cross-chain service called CCAP, which is a latest service from Chainlink. And Chainlink is a Oracle network, and based on this network, we develop a lot of the different services in Web3 field. And if you are building something like a DeFi, GameFi, or any other Web3 applications, there is a very, very decent chance you are going to need a Chainlink as Oracle to relay the data from Web2 world to your smart contract. Okay, so let me just briefly introduce myself firstly. My name is Frank, and I'm a developer relation engineer from Chainlink Labs. So I don't know if you are familiar with Chainlink Labs. So if this is the first time for you to heard about Chainlink Labs, the Chainlink Labs is a Web3 company providing a lot of the different Web3 services, just like I mentioned before. So I am a developer relation engineer, and my target is to reach as many developers as possible and to solve your problem. If you have any technical issues, if you start a new project, you want to find a job, or if you want to learn more about this industry, please reach me and I can try my best to help you. So especially in our hackathon, actually we have an ongoing hackathon from April to the June 2nd. So if you are a participant of our hackathon, please just raise your hand and tell me your questions. I really want to collect some feedback from our community about our products. Okay, so you can also find me in the Twitter and LinkedIn. And let's start. So in this workshop, we are going to have 3 sessions. In the first session, we are going to talk about what is CCIP. And as I said before, the focus of this workshop is the Chainlink CCIP. It's a cross-chain service. And in the first session, we are going to introduce the CCIP core functions, like what we can do with the CCIP and how it works, like what is the mechanism running behind the CCIP and what is the infrastructure we are going to use in with CCIP. And after that, the second session, we are going to learn more about CCIP concepts, because if you want to coding with a CCIP to build your cross-chain app, or you want to build something allow the user to send some cross-chain message, you need to learn more concepts, the programming concept from Chainlink CCIP, like what is the length, what is a router, and how you just use this concept together and to send your cross-chain message. And in the third session, which is also the last session, we are going to talk about how we are going to hand on that. So that is, I'm going to give a demo to show how to build a cross-chain app for the cross-chain NFT. In this demo, we will deploy our smart contract, like an NFT smart contract on the blockchain called a destination chain. And we are going to mint a NFT from another chain, which is called a source chain. So in this demo, we will have our fund, have our crypto in the source chain, which is I'm here, the Avalanche Fuji, and we have our NFT smart contract on the Sepolia, the Ethereum testnet. We were going to fire our transaction from the Fuji and send this transaction to the Sepolia and mint a NFT for the same address we send this transaction. And we are going to learn how to send this cross-chain message in this demo. Okay, so in the workshop, if you have any questions, just drop your questions in the chat box, or you can just maybe reach me later later after this workshop. You can reach me on the Twitter or LinkedIn, and I will help you. Okay, I think someone is asking something. Oh, okay, that is Joy. Thank you, Joy. Yeah. So for the first session, so I don't know if you are familiar with cross-chain this concept. So when we talk about cross-chain, we talk about interoperability. I mean, the first thought come to my mind is like a token cross-chain. So because cross-chain is not a very new concept, it happens, or we invented a cross-chain like many years ago, like at least 5 years ago. And when we first started doing this, we just want to cross our tokens. Or I can see that we want to move our tokens from the blockchain A to the blockchain B. And what we want to do is there is some dApp or some smart contract I really want to use, but actually this smart contract is not deployed on the blockchain where I save my crypto. For example, if I save all of my funds or most of my funds in the Avalanche, but actually there is a swap or there is some very attracting decentralized application deployed on the Polygon, how I can do that, how I can interact with my favorite decentralized application. I need to move the fund from the Avalanche to the Polygon, and then I can use my fund, use my crypto to just start using the smart contract deployed on the Polygon, right? So in this scenario, we need to cross our fund. We'll need to cross our token from the source chain to the destination chain, from the blockchain A to the blockchain B, or maybe back from the blockchain B to the blockchain A. That is the very first use case of the cross chain. But when the scenario become more and more complicated, and we want to do more and more on our business logic, because our ecosystem, the Web3 ecosystem, keep growing, and we want to move more and more business logic to the Web3. Maybe we want to build something like a Web3 version of the social, Web3 version of the swap, Web3 version of the gaming. So we have a more and more business logic. The scenario is becoming more and more actually complicated. And in this scenario, actually, we want to do more. We want to cross our tokens from source chain to the destination chain like before. And we also want to move some instructions. For example, if I want to move my tokens from the blockchain A, from the source chain to the blockchain B to the destination chain, and then stake my tokens on the destination chain and get some yield maybe, or get some other reward. So in this scenario, the token cross-chain is not only the target. I want to cross my token from the blockchain A to the blockchain B, and then just control my token or manipulate my token to be staked on the protocol. So in this scenario, we call it a programmable token transfers, which means that we not only transfer our tokens, but also transfer the instructions following our token transfer. That is called a programmable token transfers. But actually, when we talk about a cross-chain, if we want to abstract these two types of the token cross-chain, we can just see if we can move a arbitrary message from the blockchain A to the blockchain B. We actually can do anything we want for the cross-chain scenario. For example, if you want to cross your tokens from the blockchain A to the blockchain B, what you need to do is actually lock this token on the pool in the blockchain A and tell this message to the blockchain B and get some token released from the pool in the blockchain B. And by this way, you actually move the token from the source chain to the destination chain. But if you but when we come to the theory, so if you can move this message that token A is locked in the pool, please just release some tokens to this address on the blockchain B. If we can relay or move this message from the chain A to chain B, we can actually cross our tokens, or we can actually send any cross-chain message to achieve whatever we want, right? Okay, so the blockchain, the Chainlink CCIP is actually a interoperability protocol for the cross-chain message. We can just move the data, move the message from the source chain to the destination chain. So, I'm sorry. So in this graph, I just want to introduce the major components of the Chainlink CCIP. So like any Oracle service, so if you have not heard about Oracle is like a infrastructure to help the people to relay the data or computing resources from the Web2, from the off-chain world to the on-chain world. Or we can just use the Oracle to move the message or the data or token from the blockchain A to the blockchain B. So for any service provided by Oracle, we will have the two parts, the on-chain part and the off-chain part. So the on-chain part, because we are doing the cross-chain, we have two blockchains. The source blockchain, which is a blockchain we want to send our transaction. and the destination blockchain, which is the blockchain we want our where we want our message to be received. And the third part is the off-chain. The off-chain, we have the three infrastructures, three DON. The DON means decentralized Oracle network. I will explain it more in later. And we will employ these three infrastructures to relay the data or the message or the upstream message from the source chain to the destination chain. And by using this mechanism, we can move nearly everything from the blockchain A to the blockchain B to achieve the cross-chain, to achieve the interoperability. And what we need to do is, as a developer, what you need to do is just deploy the two smart contracts, the sender and receiver. In the sender smart contract, you need to wrap your request and send it to the Chainlink CCIP using sender smart contract. And the receiver smart contract is a contract where you want your message to be saved and to be received and processed. Maybe you want to send a transaction to mint an NFT. You need to unwrap this request, unwrap this message, and get what the sender want to do in the source, in the destination chain, and execute it on the destination chain. So as a developer, you need to deploy these two things, the sender and the receiver. And the rest part of this graph are developed by the Chainlink Labs. And we provide three infrastructures. We provide a router smart contract, the off-ramp and on-ramp. And we will explain more about this smart contract in the next few slides. Okay, so let's talk more about the details of the cross-chain. So we have the different phases to cross a message from the source chain to the destination chain. For the first one, called a commit. So commit means we just relay the message from the source chain to the destination chain. So as I said before, if you want to send a message from the blockchain A to B, and you need to use this smart contract, the sender, you use the sender smart contract to write what you want to send from the source chain and wrap this message and send it to the smart contract called a router. You need to tell the router which blockchain and which receiver you want this message to be sent. And the router will just do the following for you. It will just route this message to the on-ramp. And if the message is sent to the on-ramp will emit an event log. And I'm sorry, the event. Event is a data structure in the blockchain, like a log in the programming language. It will be saved on the blockchain. And if there is an event, or if there is a log to be written by the on-ramp smart contract, it will be detected by an infrastructure called a committing DON. The DON means decentralized Oracle network. Actually, we have a delivery layer like a network, and in this network we have a lot of the different nodes, and every different node will be operated by different entities. So the different node, there are a lot of different nodes under this network, and if we want to get a message or we want to get some computing resources, we just tell a node that we want to do this. The node will just broadcast the message to the whole network, and every different node under this network will just fetch the data or computing a result, and every different node will get a result, and then they will aggregate all the results together to a report, and then submit this report to an on-chain blockchain, on-chain smart contract. So what the committing done here is that there is a node under this network is used to fetch the message emitted by the on-ramp. And then the different node under this network will just check if the validity of this message, and then send this message to a destination chain. And the smart contract to receive the message is called a commit store. Okay, I think someone is dropping some questions. Okay,
Yeah,
so
I think I'll ask at the end, or what's a good time to ask?
what is the message routed through? You mean that what kind of the message to be sent from the source chain to the destination? If is that your question?
Yeah. What's the medium we are broadcasting it through? Is it regular IPs and stuff, or?
For the messenger you want to cross chain, you can do anything you like. For example, if you want to just stake some tokens, you want to transfer some tokens. What you want to just send is this message that I have already locked my token or burned my tokens on the source chain, and just send the proof of this transaction to the on-ramp smart contract. And the router, to the on-router smart contract, and the router will just tell the on-ramp that the token is indeed locked, or the transaction is indeed made by the sender, and the committing DOM will check the validity and send this cross-chain message to another blockchain. And you can write anything you like in this message.
Okay, thank you.
Thank you. Very good question. And another one is bridges. How about fee? Asked by Benrona. I hope that I pronounced it correctly. So yeah, it's like a bridges. Actually, if you want to get some data from the Web2, you want to get some data on the mid world, like the weather data, like the stock market price or any other data you want, you can consider the Oracle as a bridge to help you to relay the data from the Web2 to Web3, from off-chain to on-chain. And as for the cross-chain, you can also understand it as a bridge your message from the source chain to the destination chain. And the medium or the thing you want the bridge to relay is a message. Yeah, that is a very good question. Thanks for the question. Yeah, this is the first phase of the cross-chain. In this phase, we have a decentralized Oracle network to relay the data from the source chain to the destination chain. But here is one question I want to post here. So that is called a double standing. So I don't know if anyone of you thinking about this problem. So if I lock my token here and send this message to the destination chain, and the destination chain will release some tokens to my address. Then, but after that, after the message is crossed, if the block on the source chain is reorganized, which means the block, the chain where block is written into is not the longest chain, and the block is somehow invalid, and this transaction is reverted, and the token locked is actually not locked. So, but the token released on the destination chain is actually released to your address, which is called which will cause a problem called a double spending. So you actually not lock your token on the source chain, but you actually get some token released to your address on the destination chain, which is because the block on the source chain is reverted. It is not finalized. So how we solve this problem, or how we avoid this issue, which is I will introduce one more definition. It's called finality commitment levels. Here are three types of the commitment levels: latest, safe, and finalized. It is very, very easy to understand. So think about it, there is a blockchain from the which has 96 blocks. From the block 1 to the block 32 is called epoch 1, because for every epoch we have 32 blocks. So from the block 1 to the block 32 is epoch 1, and 33 to the 64 is epoch 2, and from the block 65 to the block 98, it is called epoch 3. And if any transactions you post it on the blockchain, you send to the blockchain is in the epoch 1, that is called finalized. So which means this block or this transaction is nearly impossible to be reverted. And the transaction or the block in the epoch 2 is called safe. The finality commitment levels for the block in the epoch 2 is called safe, which means that it is unlikely to be reverted. The blockchain, but there is still some possibilities that this block can be reorganized for in the blockchain. And for the transaction and the blocks in the epoch 3, which is called the latest. So think about it, the latest block number is block 96. So any blocks in the epoch 3 is called the latest. The finality commitment levels for the blocks in the epoch 3 is the latest, and this transaction or this blocks is likely to be reverted. It is not finalized here. So for our first phase, for our first part, the commit, the CCIP will wait this transaction to be finalized by the definition in the finality commitment levels. And when the transaction is finalized, the commit will happen. It will relay the transaction from the source chain to the destination chain. Okay. So this is a phase number 2, the blast and occurs. So as you can see here, we have three infrastructures, the committing down, RMN, and executing down. So RMN means risk management network. So the use or target of the RMN is to monitor the data relayed by the committing down. And because if something wrong in the committing DOM or more many nodes under the committing DOM is compromised by some hackers, we will have the problem, right? Because it will relay some wrong data from the on-ramp to the commit store. If the transaction relayed by the committing DOM is wrong, we will just execute the wrong transaction on the destination chain, which will cause a very severe problem. Maybe the users will lose their font, and we will have a lot of the different problems. So the RMN, the job of the RMN is to monitor everything related by the committing DOM and just reconstruct the Merkle tree proof, the Merkle tree root by the hash key, by the hash related by the committing DOM, and to see if the Merkle root is the same as on ramp, as the transaction saved on ramp. So if the Merkle tree root matches, the RMN will just certify the transaction saved in the commit store is actually valid. And and for the certification in the terminology of the CCIP, we call it blast. So the RMN will blast this transaction to see this transaction is valid and it can be trusted. And if something wrong, if the Merkle tree root does not matches on the on-ramp smart contract and the commit store, so RMN will not certify, will tell the commit store that the transaction is not good, and we call this process the curse. So if the transaction on the commit store is cursed by the RMN, the following execution will not be done by in the next phase. So the RMN is infrastructure to help to promise the cross-chain transaction is really something sent or made by the sender on the source chain. Okay, so for the phase number 3, the execute. So if the transaction is blessed or certified by the RMN, we will have the third infrastructure called executing DOM. And when this infrastructure comes to play, it will just execute the transaction blast in the commit store and use the on-ramp smart contract to send this transaction to the router. And then the data wrapped in this request will tell the executing DOM which smart contract is the receiver, because we have that address information in our cross-chain message. And executing DOM will just find its receiver and execute the transaction to this receiver and to execute what you want the executing DOM to execute. Okay, so I think someone has questions. Blast like revert? No, actually, blast is like a certify, and a curse is like a revert. But theoretically, it is not a revert. It's just a tag a transaction to see like this transaction is not valid, and it cannot be executed in the following phase. So the certify or not certify is a blast and a curse. The RMN will just certify if a transaction is valid, and it can to decide if it can be executed. Okay, here is a graph, and I think it is more easy to understand by checking this graph. So in this graph, we have three parts. Here is the source blockchain, and here is the destination blockchain, and here is the off-chain part. So as I just mentioned before, the sender, the end user will use the sender smart contract to send a transaction to the router, and router will help the sender to just find the correct on-ramp smart contract and send this transaction to the committing DOM. I'm sorry. And if the request is emitted as an event, and it can be detected as a committing DOM run by Chainlink, and the Chainlink committing DOM will just relay this message to the off-ramp on another blockchain. And when this message is related to the off-ramp on the destination blockchain, it needs to wait for the certification or wait for the blast of the risk management network. And the risk management network will reconstruct the Merkle tree root based on the hash in the off-ramp, and to see if the Merkle tree root match in the on-ramp and off-ramp. If the cryptographic proof matches, which means the transaction is really happened on the source chain, and the risk management network will certify this transaction. We also call it blast this transaction. And when this transaction is blasted by the risk management network, the executing DOM in the third place will just come here and execute this message and use the router to find the correct receiver and to execute this transaction on the receiver smart contract. And by this whole process, the end user can send a transaction on the source chain, and this transaction will be executed by the CCIP on the destination chain. Maybe you can send a transaction to just a mint NFT deployed on another blockchain other than the blockchain where you save your fund, or maybe you can just transfer some tokens from the source blockchain to the destination blockchain, and the token will be locked or burned, and on the destination chain, the token can be released to your address. And what's interesting is that the Chainlink CCIP is very general, and anyone can use that. The Chainlink CCIP will help you to relay your message from the source chain to the destination chain. Okay, let me check the questions. Could you give me main causes for blast transaction? Is there a function to predict the fee of token transfer? Yeah, there is a function to predict the fee of the token transfer. I will show the codes, and you will see in the demo part. I will show the functions we are going to use in the CCIP, and how long time it will take to transfer the messenger from the source chain to the blockchain, to the destination chain, sorry. That is a very good question. Remember that we talk about the finality commitment levels. We have the 3 types of the commitment levels. In order to avoid the double spending issue on the cross chain, it's like transaction A happens on the source chain, and then the transaction B will triggered in the destination chain. And if the transaction B is triggered on the destination chain, but after that, the transaction A is reverted on the blockchain A or on the source chain, and then the user will double spend their fund, right? In order to avoid this issue, we need to wait for the block or the transaction to be finalized, tagged as a finalized. And how we can consider it as a finalized? It should be the latest blockchain is in the epoch 3, and the transactions, the block where the transaction is saved is in the epoch 1. And at least we need to wait for the, I think, 64 blocks. We need to wait for 2 epochs and then transfer this message from the source chain to the destination chain. And this is the time, at least this is the time we need to wait to wait for the transaction to be tagged as a finalized. And how long it will take is really depending on which blockchain you are using as a source chain. If you are using the Sepolia, using the Ethereum mainnet, the block is the speed is not very quick, right? You need to wait for like 1 minute or 30 seconds, or even sometimes 2 minutes for one block produced. And in this scenario, you need to wait for 10 to 15 or even 20 minutes for the cross-chain message. But if you use a layer 2 or use some lightweight blockchain, the lightweight blockchain like layer 2 as the source chain, and you don't need to wait for a very long time. You need to only wait maybe 5 minutes or 3 minutes to for your transaction to be tagged as a finalized. So the time is really the time really depends on which blockchain you are using. Yeah, like layer 2 chains, like 3 to 5 minutes, and for the Ethereum mainnet, it will be like 15 or 20 minutes. Yes. Yeah, thanks for asking questions. Very good questions. Yeah, if no more questions, we will continue. So this is a recap, and what we can do with the Chainlink CCIP. Actually, I know the true innovation is always come from community, and I'm really excited to see which decentralized application and what type of the decentralized application you want to build. You are going to build in this hackathon with the Chainlink CCIP or other Chainlink services. And for now, I just see some potential scenarios based on the Chainlink CCIP, like collateral, governance, trading, new kinds of the dApps and enterprises workflow. For the collateral, it's like something like people want to collateral their asset on the layer 1 or on the Ethereum mainnet, and then get some liquidity on the layer 2 or some other lightweight blockchain, because people always want to save their most of their funds on the high security blockchain like Ethereum mainnet. And because the blockchain take a lot of the running by a lot of the different nodes, so it will be very expensive for you to send a transaction or do anything on the blockchain. And if you want to do the trading, you want to do some interact with a decentralized application, you need to send transactions frequently. You want to just move your fund or get some liquidity on the layer 2 on some lightweight blockchain. So this scenario is very useful for the people to just collateralize their fund on the high security blockchain like Ethereum mainnet, and get some liquidity, get some USDC or USDT on the layer 2 on the lightweight blockchain. And for the second scenario is like governance. So if you are a builder of a very big project like a Aave or something like a very big DeFi project or very big SocialFi project, and you will have a token, and different people will be your token holders. And usually for the tokens, there is a governance, there is something called governance. So the token holders can just make a proposal to say like we want to increase the fee of this protocol, we want to lower the fee of the protocol, or we want to just change some rules. Some people will just make a proposal, and different token holders can just vote this proposal to be passed or not. So in this scenario, if you have your smart contract deployed in multiple blockchains, the token holders will be in multiple blockchains. And if they want to make a proposal and other token holders want to make a vote, they need to just move their fund from the blockchain A to blockchain B and blockchain C to the blockchain D. It will create a lot of the difficulty for the users to use your application. And if you can just create a governance smart contract or create a cross-chain governance, and people can make a proposal on the blockchain, and every different people can just make the vote or whatever the blockchain they are using, and we can just create a cross-chain governance for your project. And for the third one, it's like a cross-chain trading. You can trade your crypto, just maybe swap your token A to token B, and you don't need to require the token B and the token A are in the same blockchain. Maybe the token A on the blockchain A and the token B on the blockchain B, and you can just swap the token A to the token B using the cross-chain transaction. And for the new kinds of dApps, you can think of the DeFi project or the SocialFi or the GameFi as a Lego in the different blockchains. And you can use the CCIP to connect these Legos together to create a new kinds of dApps. In this new kinds of dApps, you can just stake your tokens on the protocol 1, on the blockchain 1, and get some yield on the protocol B and on the blockchain B, and maybe just do something else on the third blockchain with the third protocol. You can just not limit your functionalities, your smart contract within only one single blockchain, but using the different blockchains to connect them together to just create a new kind of dApps. And for the last scenario, I can suggest this enterprises workflow. As you can see that we have some new concept called RWA. So the bank or financial institute want to just post their asset or just upload their asset to the blockchain to increase the liquidity of their asset. And usually they will build their own blockchain and like a bank chain, like an app chain or whatever they call it. And they will issue their asset on their own blockchain. And if they want to sell their asset to the others on the in other areas, in other banks or in other companies, they need a cross-chain, they need an interoperability protocol to connect them together. So the people in the different blockchain can just buy the asset residing on other blockchain. This is for the enterprises workflow, and maybe you can consider it about RWA or deeping, something like that. Let me see if there is any question. No question. Oh, pretty good. So if you have any questions and if you want to learn more about anything I am talking, maybe just drop your questions in the chat box and I will answer that. Okay, let's move on. So the second session is CCIP concepts. This is for the programming. So before we start programming with the CCIP, we actually need to know some concepts from the CCIP. The first concept is called lane. So we have the different blockchains and we want to move our message from the different blockchain to like blockchain A to the blockchain C. And we call this route. We call this LAN. We call this channel a LAN in the CCIP. For example, like Ethereum mainnet to the Avalanche mainnet. If we want to move something from the Ethereum mainnet to the Avalanche mainnet, we need to use the LAN from the Ethereum mainnet to the Avalanche mainnet. And let me just open this website, and you can see what actually is a LAN. And this is a website called. This website is ccip.chain.link/status, and you can see here we can check the status of the different LANs. Like for here it's a source chain. The source chain is a upstream mainnet, or the source chain is Avalanche mainnet. Let's say that I want to find the source chain as an Ethereum mainnet. And if I want to cross my message from the Ethereum mainnet to another blockchain, I can check all the different blockchains under this Ethereum mainnet. And it is to the Arbitrum mainnet or Avalanche mainnet. So from the Ethereum mainnet to any of these blockchains listed here, we call their different LANs from the Ethereum mainnet to the different blockchains. And there is one thing to be noted. What is that? Yeah, sorry. One thing need to be noted, that is from the blockchain A to the blockchain C is a LAN, and from the blockchain C to the blockchain A is another LAN. So it is not the same thing. So we need to use totally different configurations from the A to C or back to C, or from C back to A. Okay. So the second concept we want to know is called router. So remember in the graph we introduced about Chainlink CCIP major components, we have the smart contract called router. The router is like it's a smart contract to help you to relay your message to the correct blockchain and a correct receiver. I mean the smart contract, you want this transaction to be executed. And how we can find the correct blockchain, correct message, correct receiver. We need the smart contract router. So for every different blockchain, there is only one router. And when you want to send your transactions in the router, you need to just tell the router which is a destination chain and which smart contract you want this transaction to be executed or to be received. And on the destination chain, there is another router, and this router will be used to receive the message, receive this cross-chain message from the blockchain A, and then this router will execute this transaction on the blockchain B and find the correct, the receiver, and to help you to achieve this cross-chain message. And on the router on the source chain, you need to just approve the router to use your tokens if you want to transfer your tokens, because the router need to lock your tokens. And on the router on the destination chain, the router will deliver the tokens to the user account or deliver this message to the receiver contract. One router on one blockchain. And this router can be used to send or receive the message. Okay, the third one is called a chain selector. You can understand the chain selector as the ID for the different blockchain. Like we said before, we need to tell the router which is the destination blockchain, and the way you tell the router is using the chain selector. The chain selector is long numbers like this one, the 500 blah blah blah, and we have this very long number as the ID for the different blockchain. And if you want to send a transaction from the source chain to the destination chain, you need to tell the router the chain selector and tell the router maybe the token address and the receiver smart contract address. And the router will just deliver your message from the source chain to the destination chain. Okay, let me see if there is a question. If we can see sync transaction. Actually, it is not sync. It really depends how you understand a sync. If you think that the word sync is to just move some message or copy some message from the source chain to the destination chain, it is actually not sync, because on the source chain you may just do something like lock a token, but on the destination chain you may do something like a unlock token. So that is different. It is not the same. Maybe you do something on the source chain and you need to do something different on the destination chain. So that is not simply sync. It's like a transfer or move. Maybe the word move describes this scenario. Okay, so for the third part is a CCIP demo. So in this demo, if you have your laptop on your hands and you can code along with me, it is very, very simple and very easy to complete this scenario or complete this demo. And we have several sample smart contracts I have already saved on my disk, and I will use this sample smart contract to build a cross-chain NFT smart contract. What we will do is provide a handle for user to mint a Sepolia NFT from Fuji. So what does it mean? So that means I will deploy my NFT smart contract or USC 721 smart contract on the Avalanche Fuji on the Sepolia. So that is an NFT deployed on the Sepolia. But think about this scenario. I do not have any Sepolia Ethereum on my wallet. I only have the Fuji. I only have the token on Fuji, but I want to mint the NFT deployed on the Sepolia. How can I do that? Do I need to move my fund from the Fuji to the Sepolia and mint this NFT? Actually, we don't need to do that because we have the CCIP. We can send a cross-chain message from the Fuji to NFT to the Sepolia and mint this NFT. So what we are going to do in this demo is we will deploy the three smart contracts. The first one is the USC 721, and the second one is the sender to allow us to send over transactions from the Fuji. And the third smart contract is receiver. The receiver is a smart contract to be used to just transfer this message or transaction and mint a NFT on the USC 721 we deployed earlier, and mint this NFT on the behalf of the sender. So we will deploy this three smart contract and send a cross-chain message from the sender to receiver to mint a NFT deployed on the blockchain where I do not have any fund, where I do not have any crypto. Okay, so let's start. Let me see the questions. So the question is, will this session be accessible on YouTube? Here are great info I can show my team as intro. Actually, we have some demos on the YouTube and you can check I don't think this will be shared on YouTube, but you can go to YouTube and search Chainlink here and go to this one and go to this live here. We have some live streams, and one of these live stream is called the cross-chain DeFi demystified. I actually have this live stream like 2 weeks before to introduce this product during our hackathon. And if you want to check it again, maybe you can come to this YouTube channel and click this button, the live, and find everything you need to know. And not only for the CCIP, but also like you can see the make a tokenized RWA and how hard hat foundry, or how to just make a RWA asset, or like we actually have a series of the live stream during the hackathon from the end of April to the start of the June, and you can find every product introduction in this channel.
We can transfer other crypto, or not only tokens, with Chainlink.
I'm sorry, can you repeat your question? Or can you type the question?
I don't follow up. Well, we can transfer to coins, not only to tokens with Chainlink.
Yeah, you mean you want to transfer tokens, right?
We can't transfer coins like sols. One Solana to equivalents another chain B or destination chain.
Actually, for now, we cannot transfer tokens to Solana or any other non-EVM chains because we need to develop the router smart contract or off-ramp smart contract on non-EVM chains. We have covered most of the popular EVM chains, but in the future, the CCIP will support the non-EVM chains. For now, all the blockchains supported by Chainlink CCIP can be found here. If you cannot see the blockchain here, which means that the blockchain is not supported. If you cannot see that here.
Only EVMs. Right.
Okay, thank you. Thank you.
Thank you, Mr. Kang.
Okay, let's continue. Here is the architecture of our cross-chain NFT. As you can see here, we have a NFT ERC-71. We deployed our NFT smart contract on the destination blockchain, and we are going to use the Ethereum Sepolia, which is a testnet of the Ethereum, to deploy our NFT smart contract. And we also have a smart contract called Receiver. This smart contract will call the mint function in the NFT 721, ERC 721, and how we can know when and what address we want to mint this NFT, which is decided by the cross-chain message. Because in the source chain, we have a standard smart contract, and an end user will send their transaction through the standard smart contract to the router, and then the request will be caught, will be detected by the CCIP, and the CCIP will move this transaction to the, I'm sorry, this is off-ramp, not on-ramp, move to the off-ramp, and after this transaction is blessed or certified by the CCIP, it will be executed, and the receiver will use the necessary info from this request and mint this NFT. And this NFT will be minted on the destination chain. And in the whole scenario, we will not have any fund. We will not have any crypto on the destination chain. We only have our crypto. We have native tokens. We have link tokens, maybe some other tokens on the source chain. But we can send a cross-chain message to just mint an NFT deployed on the destination blockchain. And I'm sorry, not this link. I will just copy this 3 things in the chat box. So if you want to check the code, you can just check by yourself. Let me first copy that here. This is the first one. And this is a second one. And this is a third one. So if you have your laptop with you, maybe just code along with me, and we can finish it in like 10 or 15 minutes. Okay, so first, let me go to the NFT smart contract.
So are you which we can start first? The first link. I will-
Yeah, you get some link and the native tokens on the Sepolia and the Fuji. One page you can get it from the tokens is I think it's Chainlink faucets. You can Google that and go to this website. Let me copy this website here. And
I'm already using this token.
Yeah.
This force to get optimism tokens, test tokens.
Yeah. And
This-
you need to have your MetaMask installed. Let me just unlock my MetaMask. And you need to have the testnet and the network you want to use in your configurations. We will use Avalanche Fuji and Ethereum Sepolia. If you have your MetaMask, you just click on this button to have the Sepolia network in your MetaMask. And if you do not have this Avalanche Fuji testnet, you can go to the chainlist.org. This is a website to allow you to add the different networks into your MetaMask. And you can just search Fuji. And don't forget to check this, include the testnets. You will have this one. And click this button, click this one. The network will be added into your MetaMask configurations. Click this button, you will have the network shown here. And make sure you have Avalanche Fuji testnet and the Sepolia in your MetaMask. And then you can go to the Chainlink faucets, connect your wallet. Let's check this, like this one. And you can just check this too and go through log in with login via the GitHub and send a request. You will get some tokens. And if I change to the Avalanche Fuji, like this one, change to the Avalanche Fuji, and it will detect the configuration, the network you are using in your MetaMask, and it will show the different tokens here. You can get the link tokens and the Avalanche tokens on the Avalanche Fuji. But if you are using the Ethereum Sepolia, you will also have the link, but this is not Avalanche. It is Sepolia Ethereum. Okay. The last number on example 3 is not active. So when you click pop-up, say it is suspicious. Number 1 is not active. What do you mean by active? You mean the GIST? I'm sorry, maybe just explain more. And if you are prepared, we can go to the remix.ethereum.org. This is the online IDE for Solidity. Could you also share the code? Click up, share the pad, click up.net. What is that? Oh, you want me to create a temporary notepad for us? Not sure about that. But I copy everything in the chat box, and you can just choose what you need and just get what you want. Oh, you mean for the PPT? Yeah, I can share that. Yeah, I can share the directly use Google Slides to share the slides. Oh, I'm sorry. This should be anyone with this link. And let me copy this link and share it here. Yeah, this one. This is my slides, and if you need to have some content in the slide, just go to this link and to check everything you need. You're welcome. Okay, so if we start our remix, let me just zoom in. I'm not sure if you're familiar with this online IDE. So if you have any experience with Solidity, you may have experience with Remix. It is a very, very easy IDE for the developers to code with Solidity. And before we using that, before we start our project, we can click this one, the workspace actions, and create a new workspace. Let me choose the blank as a template because we want nothing. We just want a blank workspace, and give it a name called workshop CCIP, and click OK. You will see here, you will have a file explorer, and you can create your Solidity files in this area. Let me just create my first smart contract. Click this button, create a new file, and we give it a name called mynft.solidity. And we can just write code in this editor, but we don't need to write it from the scratch. We don't need to write it line by line. I can go to the first one. This is the first link of the GIST, and just copy everything and switch back to the remix and paste it here. Here is a code alert, which tells us that we copy everything. We need to know what we are doing, and we know what we are doing. So we click OK. And I will just explain more about this NFT. So you can see here, we just inherit this URC 721 from the Open Zeppelin. Open Zeppelin is a company maintaining the standard of the different token standard smart contract, like a token URC 21, URC 21, 721, and a URC 20, and a URC 1155. If you want to check the website of the Open Zeppelin, like this one, Open Zeppelin, you can go to the openzeppelin.com, and it has a lot of the different documentations. And here is a Solidity smart contract library. If you click this button, it even provides you a wizard to help you to build a smart contract in a very fast way, like this one, the URC 20, URC 721, and 1155. And if you click this, you can just add the functions you want in your smart contract, and then copy everything here and paste in your smart contract. And that is done. It is a very easy way for you to build a smart contract. But one thing to be noticed is that the latest version of the Open Zeppelin is 0.8.20. If you are using this version of the compiler, the blockchain you are going to deploy must have implemented the Cancun. And for the most of testnet, we are still using the Paris, the EVM version. So that is also the reason I'm seeing here. Let me see. That is also the reason I'm using the lower version of the contract. It's a 4.6.0 because I want to use a compiler version as a 0.8.19 because for the Avalanche, Fuji, or any other testnet except for the Sepolia, it is most of them are using the it's a Paris. What do I mean? This one. We have the EVM versions. The latest one is the Cancun, but I'm sorry, last one is the Shanghai. So most of the testnets are using Shanghai. So that is the reason I'm using the older version of the compiler. Okay, so this is for the smart contract of the NFT. That is a very simple smart contract. We only write one function called SafeMint. If you call this function with the address, the NFT will be minted to this address. The token the token ID will be incremented, and we call the SafeMint, which is a function contained in this ERC 721, and we don't need to write it because we inherit this smart contract. And then we will set the token URI, and I have this token URI. It is a image I create by AI. So it is a very cute Shiba Inu. So if we mint this NFT, we will see a very cute dog on our NFT, and I will show that. So in we can compile that, but we need to choose the compiler version, the 0.8.19, and compile that. You can click this button to compile it, or use the Control plus S or Command plus S if you are using the Mac OS to compile this smart contract. And if you finish the smart compiler, if you finish the compiling, there will be a little green check mark in this button, which means everything is good. And then we can just deploy our smart contract. And in the deployment tab, you need to choose the injector provider, which will ask the remix to use the configurations you have in your MetaMask. Because this is the first NFT smart contract, and we want to deploy this smart contract on the Ethereum Sepolia. So we choose the Sepolia. And you can see here is a little tag, the Sepolia 111 and 55511. This is the chain ID of the Sepolia. And if you can see this, which means that the remix will use the configuration in your MetaMask to deploy this smart contract. And we want to deploy that. Click this button, deploy. And your MetaMask will pop up here. And confirm. This transaction will just deploy the NFT smart contract. Okay. So maybe it needs some time. So for now, we can see the smart contract has already been deployed. And if you want to try if it works, we can just mint a NFT by click this button, the save mint. And let me just copy my address here, address, and paste it in the save mint. Paste it in this box and click this button, and the MetaMask pops up. Like before, we click confirm. And by doing this, we actually mint a NFT. And we can see if this transaction is done. It is still pending. We need to wait for it is finished. And when it finished, we can check the balance of our address, this one. The balance of the address becomes 1 because there is a 1 NFT minted for this address. And if we want to check the first element URI, we can use the token URI. We can see this is what we want the NFT have as a metadata. And if you want to check this NFT visually, you can go to the OpenSea testnet, go to this website, and this is OpenSea testnet is a OpenSea this NFT exchange deployed on the testnet, and you will have this profile. And if you click this profile here, click this button. I'm sorry, here. You will see here, right? We have a NFT minted, and let me just click that. This cute Shiba Inu is minted, and it's actually minted 1 minute ago. So this is just a NFT we minted before. And if you can see this, that means you successfully deployed your NFT smart contract. And let's see what we do next. Go back to the slides. And the next one is a build CCIP sender, right? So for the CCIP sender, we need to go to this gist. Go to this one and copy that here. And I will copy everything and explain what does this smart contract do. In the remix, go back to the file explorer and create a new file called source chain minter.solidity and paste everything here. Yeah, let me just, yeah, for this one, it's called a source chain sender. And actually, there is a lot of the configurations like a router smart contract address, the link token address, and the chain selector of the Sepolia. And what you need to just care more about is the actually one function. It's called a send message pay link. So what does this transaction function do? It will just help you to send a message to this receiver on the Sepolia, because we use the Sepolia as a chain selector, and we give the receiver smart contract, and then we use this one, the client.evm to end message, and to wrap everything together. It includes the receiver smart contract and the data we want to move. The data is a function call. We use the ABI.encode with signature, which is a safe mint. We have the function we have there, the safe mint, and we give it a parameter called address, and we use a messenger.sender, which is your what is address, as a parameter into the safe mint, and we just use a encode function to encode everything and put it into a bytes variable, and this is for the data. And the third one is the token amount, because in this scenario we do not have any token transfers, so we can ignore it. The next one is a gas limit, which means how many gas limit you allow the CCIP to use to execute this transaction on the destination chain. So if you just wrap everything together, and you can create an EVM to any message. It is called EVM to any message because we in the future will support the non-EVM chain. So it can be the EVM to any blockchain. So it's called EVM to any message. And after this message is created, you can just use a router and a router to just get a fee to calculate how much fee it will be costed in the destination chain, and to check if you have the enough balance to pay the fee. And if you have the enough balance, the link token will be approved on behalf of you to the router to use, because when the router route your message, it need to charge the fees. And then we can call this router.ccip send, tell the router which chain you want to send and what you want to send, the Sapolia chain selector and the data you created here. And the messenger can be sent from the Fuji to the Sapolia. Okay, so for now, I have a hard-coded the router in the Avalanche Fuji and the link address on the Avalanche Fuji and the chain selector of the Sapolia. But if you want to make this smart contract more general, you want to dynamically change the router address, the link address, and the chain selector, you can just input these parameters in the constructor or in the send message pay link function, and whatever you want, you can just make this dynamically. But for simplicity, I hard-coded every configuration. Okay. Okay. Let me see the questions. So the question is why we use the Solidity instead of the native JS lives. Because we want to create our smart contract. The JS cannot be used to write the smart contract. If we have some smart contract, or if we have the smart contract library, we can use a JavaScript to just create to deploy this smart contract, or just interact with some functions within this smart contract. But in order to create a new and a brand new smart contract, we need to use the Solidity, and maybe there are some other programming language for the smart contract, but Solidity is the most popular one. That is why we use the Solidity to create our smart contract.
So,
and gas limit or the standard ETH fee. Well, actually, the gas limit and the gas fee are two different definitions, because the gas fee is actually the gas limit multiply the gas price. So you can calculate the gas limit based on the complexity of your transaction. But the gas price is decided by the traffic of the blockchain you are using. So if the traffic is pretty high, that might cause something called a gas spike, and you need to pay more gas fees to make your transaction to be mined. But if the traffic of the blockchain is not that high, it is low, the gas price is lower than before. So the gas price is calculated based on the complexity of the transaction, and multiply the gas price, and you can get the ETH fee and get the gas fee, and you need to pay the final gas fee for your transaction to be mined. And what is a programmable token transfer? The programmable token transfer is not only transfer the token, but also transfer some message with your tokens. After the token is transferred, you want this token to be staked or to be collateralized, or any other manipulations you want you want this bond with these tokens. That is called a programmable token transfer. Okay, let's continue. Let me just compile this smart contract. And like before, we have the little green check mark, and we go to our deploy tab. And be careful, because we have the standard smart contract here, so we need to deploy this smart contract on the source blockchain. The source blockchain we are going to use is Avalanche Fuji. So we need to go to our MetaMask and go here to switch our configurations from Sepolia to Avalanche Fuji testnet. And here we have our Avalanche Fuji, and we can see the line behind this environment is a custom and a chain ID network, which is Avalanche Fuji. And let me just deploy the source chain minter and deploy that. Your MetaMask pops up, and like before, confirm this transaction, and this smart contract will be deployed. Wait maybe for several seconds to for this. Yeah, this smart contract is deployed successfully, and we can see here are some functions, and we are going to call this send message functions. And we need to input the receiver address, but we have not deployed our receiver address, receiver smart contract yet. So we need to first deploy our receiver smart contract on the destination chain. And let me go to the third smart contract here, the CCIP receiver. Now copy this, go to the third gist. In the destination chain receiver. And let me just copy everything. And like before, I will explain more in the remix. Go back to remix, and in the file explorer, just create a new smart contract called the destination chain, dest chain receiver. Maybe we can call it receiver.facility, and then paste everything here. Let me close that and compile that. And for this smart contract, actually, we only have a very simple function called CCIP receive. And the CCIP receive has a one parameter called any to EVM message. Remember, we have create our EVM to any message here, the EVM to any message. And for here, we will going to receive this EVM to any message, but we'll give it a different name called any to EVM message. And when we get this message, we will get this data and use the call function to get the address of the NFT and execute the data on the NFT smart contract, and to see if that is successful or not. And if the transaction is executed successfully, we will get a true as a Boolean variable here, and that means the mint is successful. And if this variable is false, we will just reverse this transaction and give the error information called mint failed. So I also hard-coded the configurations in this smart contract, like a router address and BM tokens. We don't need to care about that. We do not have the token transfer here. So this smart contract is used to receive the EVM to any message sent from the CCIP from the standard smart contract, and unwrap this message, get the data, and execute this data on the EVM, on the NFT. And the way we got the NFT is that we need to input the address of this NFT, and we have the interface of this NFT here, just to notify that we have a function called a SafeMint in the NFT. And in the constructor, we will instantiate this NFT smart contract with the interface we created here. And then we will have the handler of this NFT in our receive functions. We will use this handler to execute the transaction and mint NFT. Okay, cool. So let me deploy that. So because this is a receiver and need to be deployed in the same blockchain as a NFT smart contract, so I need to switch from the Avalanche Fuji back to Sepolia. Just don't forget this step, back to Sepolia, And when you see the line here is the Sepolia, then that is correct, and you need to use the Sepolia. And in the CCIP receiver, let me compile that again. And here, the deployed in the constructor, we need to input one parameter called NFT address. And because we have already deployed our NFT, we copy here by clicking this button and paste our address here and click deploy. And the MetaMask pops up and click confirm here. Okay, we're deploying our receiver.
I will use the second read to send you a message. So you can verify my message using the third read.
I'm sorry,
hope-
can you type your questions in the chat box? I'm really sorry. I just don't get that.
Sorry?
Can you type your question in the chat box?
It's not a question. It's I just want to execute the second JIT that you sent to us, so you can verify the message that's already sent by me to you in the remix.
Okay, you're deploy this one?
Second, okay, yeah.
Yeah.
If possible, if I succeed.
You mean you don't know if that is successful, or what do you mean?
If I succeed to send message using this Solidity code, so you will verify it by the third digit. If I can say the third digit is to verify or to verify that message are already received. Okay.
Verify what? You want to verify what?
Verify that message or received successfully or what? As per my check.
Oh, you mean you want to verify if the receiver exists or not in this function?
I use this one that function to send message. So you
Maybe we can talk about later. Let me just finish this demo, and maybe we can just talk about your question later. Is that okay? You can just reach me by any channels, maybe Discord or the Twitter or anything you want. Yeah, it's I'm sorry, it's almost done, and I think you have a lot of questions, and we can talk about it later. Okay, thank you. Yeah, this is for the third smart contract, and in order to, oh, I'm sorry, I have already deployed this smart contract, the destination chain receiver, and now we can just send our smart cross-chain transaction. And if we want to send our transactions, we need to switch to the, I'm sorry, to the Avalanche Fuji and go to our source chain standard. And actually, this is a smart contract we want to, this is a function we want to use to send our message. And there is a one parameter called a receiver, and we need to copy the address of this receiver and paste it here. So for the send message pay link, we can go to the source chain linter. This one, we receive the parameter as an address and tell the CCIP what is the address of the receiver on the destination chain, and then we create the data we want to send, and we can wrap everything into a message and send this message by the router here. Router, yeah, this one, the router send CCIP and to just relay this data we want to execute from the Fuji to the Sepolia. And by clicking this button, we will just send our first cross-chain transaction. And if I click it now, we actually will have the problem called a gas estimation failed. It is a very general error in the remix, which means that you do not have a permission or you do not have enough balance to send your transactions, and so the remix cannot estimate the gas costed on this transaction. And in order to solve this issue, we just copy the address of the smart contract and transfer some links to this smart contract. And copy that here, copy the smart contract address here, and then click this drop-down list, click the link, and maybe we just transfer 10 links to this smart contract, and then click next, and confirm. Okay, we need to wait for this link to be transferred to the standard smart contract. Yeah, this token has been transferred successfully. And then if we click the transact, and the MetaMask pops up, and we can click confirm. And from now, we have already sent our cross-chain message from Avalanche Fuji to the Sapolia. And when this transaction is mined, we can go to the MetaMask, go to the activities here, and copy the transaction ID. Click this, and go to the CCIP Explorer, ccip.chain.link. This is the explorer of the CCIP messages. Let me paste it here. And if you go to this link here, and I'm sorry, to copy that transaction ID, this one, copy the ID and paste your ID here. You can see the transaction details. This is a cross-chain transaction details, which has a messenger ID, the source chain hash, and a destination chain hash. The source chain hash is a hash I just copied, and the destination chain hash is a transaction that will be executed on the destination chain, and there going to be a hash. Well, we do not have it yet, but when this transaction is relayed, we will have this transaction hash. And the status is the status of this cross-chain message. Remember that we have the commit and finalized and blast and executed. We have the different phases of the cross-chain message. For now, it is a blast. That means this transaction is blasted by the RM, and now it turned to success, which means this transaction has been successfully executed on the destination chain by the CCIP. And we will also have some the address of the sender and receiver, and we have the fees, we have the source chain, the destination chain. You can find nearly everything on this CCIP Explorer. And since that is a success, we want to check it again on our OpenSea. We can see if we have one more NFT or not. See, we have a two. We have a two for now. And if you go to the remix and change it back to the Sapolia, and go to the NFT smart contract here, and go to the balance of the address, you can click that again. It will be 2. That means under this address, there are 2 NFTs. The first one is minted by us by calling the safe mint, and the second one is a mint from the Fuji, and we do not have any fund on the Sapolia, but we have some fund on the Fuji. We can just send a cross-chain message from the Fuji to mint NFT, which is deployed on the Sapolia. So this is a whole process of this demo, and let me see what are left it. Yeah, so in the finally, I will just spend 1 minute to talk more about our community. So we have a documentation. The link is docs.chain.link. You can nearly find everything about Chainlink in this documentation, and everything I talked today can be found in this documentation, like CCIP examples and the examples of other Chainlink products. You can find nearly everything in this documentation. And if you still have any questions, there are two channels. So the first one, for if you want to just chat with us, chat with me, please go to the Discord of the Chainlink, and the discord.gg/Chainlink. This is our Chainlink channel, our Discord channel. And in the Discord channel, we have a multiple channels, and you can find the VRF, you can find the CCIP, you can drop your questions in this channel, and there will be someone answering your technical questions. And you can also post your question in the Stack Overflow exchange. And if you post the questions here, don't forget to tag Chainlink on your question. And if you tag the Chainlink, we will answer your question. We have a team. Actually, it's my team, the developer relation engineer team, to answer the questions tagged with Chainlink every week. And that is pretty much I want to talk today. And thanks for your time. And thank you again for coming to this workshop. So yeah, thanks for your time. And
how we can participate, so we can execute your gests. How you can elevate our applications, if I can say. Well,
actually, can you go to the Discord and type your questions? I'm sorry, I just cannot on. Yeah, maybe go to the Discord and type your questions. Yeah, thank you very much. Sorry for the inconvenience.
So where we execute this, what have learned with you. It's the first time I learned this Solidity. I heard it before, but it will be the first time that to execute a Solidity codes or macro apps to mine everything or to send smart contracts. Thank you.
I suggest you join our Discord. There will be our developer and dev expert who can help you answer all the questions. You can also DM Frank on the Discord and talk if with any question you have later. So yeah, I think that would be easier than chatting here. Is that okay?
Very, very good.
Yeah. I post the Discord link to the message. Please click on that link and join our Discord, and you will find Frank or me or other developer who can answer all the about Chainlink related question.
Thank you, Miss Joy. I will reach out.
Thank you, everyone. I hope you happy building on this hackathon. And if there is any question, please reach out to us on our Discord, official Discord of Chainlink.
It's gonna be recorded. That are you going to share?
Yeah. It will be recording.
Okay, perfect.
Thank you.
Thank you, Joy. Thanks, everyone.
Thank you, guys. Thank you, Frank. Bye-bye.
Sure.